Hi there, my name is Graham Lewis, and in this video we're going to explore the confidence interval for a mean. Now, I'm not going to go through in this video how to get the critical values 1.64, 1.96, 2.58. If you haven't watched my video, What is a confidence interval, then I would recommend you do that. So for the margin of error for means is slightly different to proportions in that it's the same Z stars, so the same critical values that you're going to choose for your three levels, 90%, 95 and 99%, and these are the Z star values, critical values, but this formula is slightly different. It's sigma over root n. Now remember, sigma is the population standard deviation. Now we're not going to know the population standard deviation, so we're going to estimate this with the sample standard deviation. So we're going to use S, the sample standard deviation from a sample. So let's do an example. So I really like this example because this shows why finding samples and doing confidence intervals is so important, because clearly we would not want to do a census here, because what we've got here is testing light bulbs in a factory and how long they last, and we've got the number of hours they last for a particular manufacturer. Now obviously there's no point doing a census, because if you used every light bulb until it kind of failed, you're not going to make a lot of money now, are you? So clearly the manufacturer wants to know if their claims are correct, that the light bulbs have a mean of 1200 hours and a standard deviation of 420. So we've got here a sample of light bulbs. The first thing we have to do is work out the sample mean and the sample standard deviation. I'm going to use Excel to do that to speed things up. So here I've entered the light bulb lives in an Excel worksheet, and we've got 12 light bulbs, n is 12, so let's work out the sample mean. Well, the sample mean, you just type in A equals AEV to find average, and it tells you there it's the arithmetic mean, so we'll double click on that, highlight the cells, close the bracket, Bob's your uncle. So we've got a sample mean of 1232.75. That's not far from their estimate. Let's work out the sample standard deviation, so equals ST. I want the standard deviation of the sample, so STDEVS, estimate standard deviation based on a sample. So that's the one I want. Double click on it and highlight your light bulbs again, close the bracket, and Uncle Bob appears again. So we've got a sample standard deviation of 288.83 hours, or 84 hours. Okay, so let's copy that into our OneNote. So to work out our 95% confidence interval, we need to find our margin of error, which is our Z star value multiplied by sigma over root n. So because I'm at the 95% level, I want to use a Z star value of 1.96 and multiply that. We don't know sigma, we're going to use our sample standard deviation as an estimate. So 288.84 divided by the square root of 12. And let's just work that out. And popping that into my calculator, I get 163.4 hours. So now we can work out the confidence interval. So we've worked out our margin of error of 163.4 hours. And remember, to work out the confidence interval, we take the estimate, our sample mean, x bar, and plus or minus our new margin of error. So we got from our data, our sample mean of 1,232.75 hours, plus or minus our margin of error, 163.4 hours, and that gives us a confidence interval from roughly 1,069 to 1,396. And now we need to interpret it using our classic sentence. So our classic sentence is, I am % confident that the true, whether it's proportion or mean, of whatever it is between and . And now we fill in the blanks. So let's do that by magic. And there we have it. I am 95% confident that the true mean of the light bulbs for this manufacturer, we don't know which manufacturer, is between 1,069.4 hours and 1,396.2 hours. Notice I chose to round to one decimal place there because I didn't think 2 was really needed. So you can decide how many decimal places. Now the manufacturer claims that their light bulbs last 1,200 hours. So that's fairly reasonable because that lies inside our confidence interval. If it lied outside our confidence interval, then we would say that maybe they need to readjust what they're claiming for their light bulbs. Now let's do a 99% one, and it's your turn. So now pause the video and you're going to do a 99% one, and then we'll go through it. And remember, the Z star value for a 99% one is 2.58. So pause the video and then we'll compare answers. Let's see if we got the same answer. So our critical value is 2.58 for a 99% level. The margin of error therefore is 2.588 times our sample standard deviation estimate, 288.84, divided by the square root of 12, because our sample size is quite low, 12, giving us a margin of error of 215.12 hours. Adding and subtracting that from our estimate of the mean gives us our confidence interval of roughly 1,000 to 1,500 hours. So we can finish that off with a nice sentence. I am 99% confident that the true mean of the light bulbs for this manufacturer is between 1,017.6 hours and 1,459.8 hours. What do you think? Did you prefer the 99% one or the 95% one? Pause the video, have a think, and then I'll give you my thoughts. I'd love to know what you thought. I'm thinking here that the increase in confidence isn't really worth increasing the width of the interval. So I actually, in this case, prefer the 95% confidence interval. That's because our sample size is so small of 12. Ideally, we would want a much larger sample so we can narrow this width down and hopefully have good confidence. Maybe because it's such a small sample, a 90% confidence interval might be better. You've guessed it. It's time to pause the video and you have to do a 90% confidence interval, and remember that the Z star value for that is 1.64. So pause the video, try it, and then we'll compare, and then we'll look at all three and decide which one we prefer. So everything is the same as the previous two examples, except the Z star, the critical value, is changing to change that 90% level. So we've got our Z star now is 1.64. We've still got the same sample standard deviation and the same sample size, so divide by root 12, and I got 136.7 hours, which is my smallest margin of error out of the three, but I've got the least confidence in it. So remember to work out the confidence interval. You do X bar plus or minus margin of error. And I should point something out. You've probably noticed that always write down the formulas. This is really good practice, always to write down the formulas, because then you'll remember it and understand it more easily without having to learn it by rote. So always write down the formulas and then put your number in. So I've got my sample mean of 1232.75 plus or minus my margin of error here, which we worked out, giving me a confidence interval roughly from 1,096 to 1,369. So I'm 90% confident that the true mean of the life of the light bulbs for this manufacturer is between 1,096.1 hours and 1,369.5 hours. Let's have a look at all three, and then you can think which one you prefer out of the three. So here we have our three confidence intervals, and you can see as we've got more confidence, we've got a wider interval. So 99% confidence, we're going from 1,017 to 1,459, so you can see the margin of error is bigger there. When we decrease the confidence, only being 95% confident, our interval is a little bit narrower. So with less confidence, we've got a smaller interval. Smaller interval is nicer. 95% confident is still good, I think. And when I'm only 90% confident, which means that if you were to do 100 confidence intervals, 100 different samples, only 90 of them would capture the true mean life of the light bulbs, which is not that high confidence level, but obviously you've got the narrowest of widths, which is nice. But I don't think the width here is that, it is better than this width, but it's not, to me, massively better that I want to drop my confidence level. So I would choose the Goldilocks one in this example personally, and I would go with 95%. But in future, I would rather have a larger sample size than 12. Because if I have a larger sample size, then my margin of error is lower, and maybe I could even go up to that 99% level. Or at least have a 95% level, which is a narrower interval. All of them have 1,200 lying in them, which the manufacturer claimed it was 1,200. So all of them support the manufacturer's claim that their light bulbs last 1,200 hours, so no need for them to change their advertising. So I hope you enjoyed that and found it useful. Have a great day, everyone, and thank you very much.